everyone, welcome to Chemazon-Complete Chemistry. So in this video we are going to start with a new video series, that is we are going to learn NMR spectroscopy. So the first thing is we are going to learn is what is the basic principle for NMR spectroscopy. Okay, so have you ever played with a top? I'm sure you might have played with a top and it spins like that. So any nuclei, okay, generally we are talking about NMR active nuclei. What is the meaning of NMR active nuclei? I will tell you in a while. So any nuclei or nucleus in particular, whenever it is present in the presence of a magnetic field, okay, it will rotate like this. It will undergo precessional movement. Okay, precessional means rotation like this. Top is rotating. Okay, this movement is called as precession. Okay, so every nucleus, okay, every nucleus that is present, for example, let's say 1H, okay, hydrogen, or generally we call this as proton. Okay, the nucleus 1H or any nucleus, when it is present in the magnetic field, it behaves like a tiny bar magnet. Okay, it behaves like a tiny bar magnet. Okay, so what exactly happens when you place it in the magnetic field? It starts spinning, okay, or it starts rotating across its axis. Okay, when it is present in the when it is subjected to magnetic field. Okay, when it is subjected to a magnetic field. So when there is no external magnetic field, what is the spin of the nuclei? It is randomly oriented. Okay, it is random. Okay, there is no direction. But when you apply a magnetic field or place it in a magnet, a very strong magnet that is called as electromagnet, what will happen is the nucleus, it will either align with the external magnetic field. B0 is the external magnetic field. Okay, direction of the external magnetic field. Okay, it will either rotate anti-clockwise like it is shown here. Okay, anti-clockwise, that is one of the energy state that is called as the alpha state or alpha spin state, or the other possibility is it will rotate clockwise. Okay, it will rotate clockwise, that is the higher energy state or called as a beta energy state. So these are the two possible ways of alignment. Okay, either it will be aligned parallel to the external magnetic field or anti-parallel. Okay, so that gives rise to the two energy state. One is the alpha state and the another is a beta spin state. When it is aligned with the magnetic field, as you can see here, a magnetic field direction is this red one, external magnetic field, and nuclei direction is also same, then it is alpha spin state, that is lower in energy. Okay, or the other state is where it is opposite. Okay, the direction of the field of the nuclei is opposite to that of the external field, that is higher in energy, called as beta spin state. Okay, and then energy between them is this, it is given by this formula, we'll discuss in a moment. So basically what happens is, whenever you place any nuclei in presence of the magnetic field, it will form two energy states. Okay, two spin states, either alpha or beta. Okay, and what does this frequency depend on? The frequency of the electromagnetic radiation. Okay, generally which frequency we use in case of NMR? That is the radio frequency that we are using. Okay, that you must know, we use the radio frequency. Okay, that is directly proportional to the magnetic field. Okay, the stronger the magnetic field, okay, larger will be the difference between the two nuclear states and greater is the energy needed for resonance. Okay, what is the meaning of resonance? We'll understand in a moment. So frequency, it is directly proportional to the energy, and energy is in turn proportional to the magnetic field. Okay, we know E is equal to h nu, that is energy is directly proportional to the frequency. Okay, and this energy difference delta E, it depends on what? It depends on the B, okay, or the magnetic field of the instrument. Okay, in the next video we'll see how, what is the exact instrumentation of the NMR machine. Okay, so magnetic field, it is measured in what? It is measured in Tesla. Okay, so greater is the value of magnetic field, greater will be the energy difference between the two spin states, and we say higher will be the sensitivity. Okay, sensitivity of the instrument. Okay, or we can say what we will get, we'll get better resolution of the NMR spectrum. Okay, the spectrum that we get, that will be of the better resolution. Okay, that is why we say that suppose I have a 500 megahertz instrument that will have a better resolution, or let's say better splitting pattern, that we'll see in the coming video what is the meaning of that, as compared to an instrument having, let's say, 400 megahertz. Okay, so the sensitivity is higher. So here you can see, as the value of external field increases, the spin states between the, or the energy states between the nuclear spin increases. Okay, and what is that energy equal to? Energy is equal to h nu, and what is frequency here? Nu is equal to, okay, we saw just now, nu is directly proportional to the external magnetic field B naught. Okay, and if we write a proportionality constant, that will be nu is equal to gamma by 2 pi, that is the constant, into B naught. Okay, what is this nu? Nu is the precessional frequency. Nu is the precessional frequency. Okay, in the first slide that I had shown, okay, any spin, okay, any nucleus that will undergo spinning, okay, spinning across one axis, okay, with some frequency, okay, that spinning of the nucleus, okay, precessional frequency of the nucleus is nu. Okay, this is called as a, nu is nothing but called as a precessional. Why it is called precession? Precession means the movement like a top, okay, spinning top. The first slide that I had shown, that movement is called as precession. Okay, so that is why this is called as precessional frequency, or another name is Larmor frequency. Larmor frequency. What is H? H is the Planck's constant. Okay, gamma is called as a gyromagnetic ratio. B0 is the magnetic field, whose unit is measured in Tesla. Okay, so many times this question is asked based on this formula. Precessional frequency is equal to gyromagnetic ratio into B naught by 2 pi. We'll solve questions based on this formula in the next video. Okay, and the final question is why it is called NMR. Okay, why the name is given NMR? What does it stand for? Nuclear magnetic resonance. Nuclear magnetic resonance. So why it is called nuclear? Because in nucleus is involved. Okay, nucleus of any atom is involved. Okay, whether it is 1H or 13C or 19F and so on. Okay, so magnetic, because magnetic field is present. Okay, it is, the nucleus is placed in presence of a strong magnetic field. Okay, and why it is called resonance? What is the meaning of resonance? So whenever we apply a radio frequency, okay, RF, okay, and what is the meaning of resonance? Resonance basically means the matching of the frequency. The meaning of resonance is matching of frequency. Now, which frequency here we are talking about? When the radio frequency, okay, the frequency of the radio waves, okay, frequency of the radio waves exactly matches with the precessional frequency. Precessional frequency means frequency of the nucleus. Okay, this matching of frequency, when the frequency of the radio wave is same as that of the nucleus, what will happen? It will absorb that, the nucleus will absorb the radio wave and then it will undergo flipping. Okay, initially the spin state was like this, after resonance it becomes like this. Okay, so it moves to, it goes to a spin which has a higher energy state, that is beta. Okay, it moves from alpha to beta. When this occurs, when the radio frequency is same as that of the frequency of the proton, okay, or any nucleus that we are taking NMR. Okay, so nucleus is in the state of resonance when it absorbs RF radiation, and this process of changing of spin, this is called as flipping. Okay, this phenomena is called as flipping. Okay, or it is also called as spin flip. Okay, to a higher energy state. Okay, that is why it is called NMR, and because nucleus is involved, and M because magnetic field is present, and R is resonance because there is matching of frequency. Which frequency? Frequency of the radio wave and the precessional frequency nu. Okay, so that's it for this video. I hope you have understood some basic principles like what is NMR, why it is called NMR, okay, and how the precessional frequency, it is directly proportional to the external magnetic field. The third important thing is the formula that we saw just now, delta E is equal to h nu, where nu is the precessional frequency, that is equal to gamma, that is the gyromagnetic ratio, B naught external magnetic field divided by 2 pi. Okay, I hope you have understood all these concepts. In the next video we'll see what are the conditions for NMR active nuclei. Okay, not all the nuclei will be NMR active. NMR active means it will absorb RF frequency or radio frequency pulse. Okay, not all the nuclei are NMR active. So what is the condition for NMR active nuclei, that we'll see in the next video, followed by the instrumentation of the NMR instrument. Okay, I hope you have understood this. Thank you.